So for question 2, we have a rectangle 1 that has a length of x and a width of y. So I'm going to just sketch a small rectangle. We'll call it rectangle 1. We'll label the length x and the width y. I'll sketch a larger rectangle. And we get the length and the width by multiplying the original dimensions x and y by a factor of k. So the width is going to be k times y, and the length is going to be k times x. So I'm labeling those length and width. We want to know if rectangle 1 and rectangle 2 are similar. And we can say yes, they are similar, but we need to say why. Each of the angles in a rectangle are 90-degree angles. So all of the angles in the rectangle are congruent. X relates to y in the same way. That's the length and the width relate to the larger rectangle 2. The relationship of the length and width is k times x to k times y. Now you can factor out or cancel that k, and so those proportions are similar. Those sides are similar lengths because they are proportional. You can write this in words, or you can simply do what I did and show your work. A paragraph proof just means in your own words. So for C, we want to write a proof to show that the area of rectangle 2 is k squared times the area of rectangle 1. So we're going to use these two diagrams that we have. Area is length times width. So for part C, the smaller triangle, the area is x times y. And the larger rectangle is kx times ky. Don't know why I keep saying triangle. I just like that word, I guess. Alright, this we can rewrite as k. I'm taking out one of the k's, putting it up in the front. I have another k as well. So I have k times k, which is actually k squared times x, y. So we'll see that the area of the larger rectangle is the area of the smaller rectangle times k to the second power. So whatever that scale factor is, in our problem it's k. When we compare the relationships of these two rectangles, it increases by k squared. Now let's move on to question 3 and do something similar. You can write it out in words, but for me it's easier to just show my work. A sculptor is planning to make 2 triangular prisms out of steel. Now the sculptor is going to use triangle ABC for the base of one prism and triangle DEF for the bases of the other prism. Now remember that prisms the bottom and the top are the same, it's not going to go up to a point like a pyramid. It's going to go up to the same identical image as the bottom. So you have two bases, the top and the bottom. So the volume is going to be the area of this triangle, and the area of the triangle is length times, or base times height, divided by 2. That's the area, or we call it a capital B when we're going into volume. So the area of the base times the height would be our actual volume. So right now we have the area of that triangle. 50 times 20. Let's go ahead and calculate that area of the base so we'll have it if we need it. Is 1,000 divided by 2 is going to be 500. So if we're going to go further, and we will a little bit later, we simply take that area and divide it by the height to find volume. So let's look at the area of this second triangle, triangle DEF. The base of that triangle is 24 times the height is 60 divided by 2 will give us the area of this triangle, which is going to serve as, well, both of the bases, the top and bottom, will both be the area of 720 square units. So if we have a height, we'll simply multiply it by the height to get the volume. So is triangle ABC similar to DEF? So let's compare the parts of the triangle that we can see. So I'm going to start with that 90-degree angle. So we have two angles that correspond, that are congruent. Now we want to look at the relationship between the height of both triangles. So I'm going to write it as a comparison of 50 to 60. Now let's compare the other two legs, or the base of those triangles. And I'll start with the same triangle, 20 over 24. Now let's see if those two comparisons are equal. So I'll change the color of my pen, and I want to multiply 50 times 24 and just see what happens. So I'll get my calculator out, make sure I do this carefully, and I got 1200. I'll multiply 60 times 20, and I'll also get 1200. So this is showing that these are proportional. So we have a relationship of two sides, an angle, and another pair of sides. The sides are proportional, the angle is congruent, which proves that these triangles are similar. Now we're going to go on to B. Suppose that the sculptor makes both prisms the same height. So I'm going to just use H as the height. We've already calculated the area of each triangle. So the area of each base is 500 and 720 respectively. We're going to multiply each times H. Which prism will have a greater volume? Well, you can see 720 is greater than 500. So the second prism is going to be greater. And the amount, how much greater, we get by taking that second prism, 720 times H is the volume, dividing it by 500 times H, the original prism. The H's cancel, and then 720 divided by 500. Put whatever numbers you have on your test into your calculator, and I get, it increases by a factor of 1.44. So it's 1.44 centimeters times greater. 1.44 times greater. And this is how you work it out. If you prefer to write it in words, that's fine. Or you can just leave your answer like I have by showing your work.